Hello everyone, welcome to 2.1. Use the language of algebra. So we look at these following objectives in this section. We look at variables, expressions, and equations, how they differ from each other. And we will be using those algebraic symbols to describe these items. We also will look at exponents and order of operations. Very important topics for our, to set the stage for algebra, and this being pre-algebra, we'll take the time to get through these things. All right, let's try to understand why we need variables and why we need this language of algebra. The language of algebra requires that we start talking about math, not just in terms of numbers and just the symbols, but to give meaning to what those symbols stand for, and also bring in more operations that beyond what we've seen so far. We've only seen, in terms of arithmetic, we've only seen plus, minus, multiplication, division, right? But we do have other operations, plenty of other operations we need to use in math, and you'll understand why we need them and how it really helps us. So it is to expose ourselves to algebraic symbols, as well as understanding what role variables play in math. Okay, why is algebra so important? So let's say, let's say my brother and I are 3 years apart. Okay, so when I am 5, okay, when my brother is 5, I will be 8. So brother and sister. Okay, so in this hypothetical example, we have when the brother is 5, the sister is 8. When the brother is 7, the sister is 10. When the brother is 20, the sister is 23. So if you look in each of these, what we call them data, right? And so in these entries, you see that, as I mentioned, we are 3 years apart. Okay, so there is 3 years in between us. Therefore, when I give specific numbers, then you add 3 to it, right? What if I want to generalize this? Then I can say the age of my brother, I can call it by some letter B. And what will be the age of the sister? Whatever B is, it will be 3 more to that B, right? So B plus 3. And then I'd have to go back and reference as to what this B stands for. B stands for the age of the brother. So notice how we are reducing excessive words or language or specificity into something more general, while still sticking on to the use of a letter. The use of this letter is the very idea of variable, because when we say variable, the word itself contains the word vary, which means it can vary in value. So by generalizing this information and by calling it a B, B can take any value, right? B can vary. B can be 7, therefore B plus 3 will be 7 plus 3, 10. B can be 20, so that B plus 3 will be 20 plus 3, 23. B can be 11, so that B plus 3 will be 11 plus 3, 14, and so on. So because of the flexibility, the variable nature of B, we can generalize it as well as keep it crisp, isn't it? So we can just say that the age difference between the two siblings is 3 years, and we can in particular set a variable for the brother and give the variable for the sister. You can also do it the other way around. If I set a variable for the sister where S stands for the age of the sister, is there a way we can find a corresponding expression on the other side for the brother? Yes, the sister is 3 years older to the brother. Therefore, the brother will be 3 years younger to the sister. So it will be S minus 3. So now think about this. When S is 23, the brother will be s minus 3, 23 minus 3, which is 20. When s is 10, the brother will be 10 minus 3, which is 7, and so on. So you see how beautifully the play of variables come in, right? Now let's walk through the definitions in the book. Variables and constants. So you have the definition here. A variable is a letter that represents a number or quantity whose value may change. It can vary. A constant is a number whose value always stays the same. Constant, that means it stays the same. So let's take quick notes on this. So we say variable, as the word contains the hint there for it is vary. So variable is a letter that represents a number, like in the case of age, or quantity. Okay, so it's not too wordy. You just assign a letter and then describe what that letter stands for. So if I want to find the number of oranges, I don't have to keep calling it the number of oranges each time. I can simply give it the letter O, or I can just use the letter X. It doesn't have to be the first letter of the word we are interested in. It can be anything, right? X can represent the number of oranges and Y can represent the number of apples. So you can definitely use that information based on whatever letter you want to use for the variable. Constant means it remains the same. What remains the same? Now notice that constant means that it is not changing, right? Whereas variable changes. Changes. This does not change. So a very typical example for constant is numbers, right? A variable is letter. So numbers, when I say 35, 35 is 35. 35 cannot become 36, cannot become 34, cannot become some other number. It remains the same number. So that is the idea of constant. Constant is it remains the same. It's unchanging. Now, if we talk about the notations, remember for the 4 operations we saw in whole numbers chapter. So this is what we saw, and here's a quick glimpse of all that we saw. Notice how the language is sum, difference, product, and quotient. And so when we translated, in whole numbers chapter, we gave a meaning to it through the notation by writing expressions. But here, if you see, we're talking about equality. Okay, so that is an upgrade to the expressions. An expression is a statement where you're trying to bring in notations and symbols into it. When I say equation, it's actually equating two expressions. So when we say A equals B, or A is equal to B, the equality symbol, it is a visible sign to show that we're talking about an equation and not an expression. Okay, so let me write that here. So you have equation, means it has the equals sign. So we have a mathematical expression on one side equal to a mathematical expression on the other side. That is an equation. So when we say mathematical expression, it is a collection of symbols and numbers, but it does not have any equal sign in it. So it is just an expression that is talking about an operation, a plus or a minus or a multiplication or a division. But when I have two expressions set equal to each other, then we call that an equation. And then if we have any missing information, then we go further to solve an equation to find solution to the missing information. So that's the equality symbol. And when we talk about equality, we always talk about the inequality as well, right? That goes with it. So I went to, hold on. This touch screen is rolling too fast for me. Okay. Inequality. Inequality, as the name says, is not equal. Okay, it's not equal. Equal means both sides are the same. Inequality means one side, meaning that that statement is unequal, which means one side is definitely more than the other, or in other words, one side is less than the other. When you talk about inequality, there are two ways it can go, as I mentioned. Okay, the left side, so you have two sides, right? Left side and the right side. When the left side is equal to the right side, then we call it an equation. When the left side is less than the right side, then we say the left is less than the right. When the left side is greater than the right side, then we say the left side is more than the right side. So you can see that here in the number line. When A is less than B, on the number line, A will appear before B, right? A will be to the left of B. On the other hand, when when A is greater than B, if A is more than B, then A will be to the right of B. Or in other words, because B is less, it will be to the left of A. I'd like to explain that here as well. So when we talk about inequality, if you look at our number line, the number line is unchanging. Okay, you have 0, you have 1, 2, 3, and so on. So what you see is that as we move in the right towards the right, the numbers increase, isn't it? So you see that the 1, which is smaller than 2, appears before 2 can appear, because it's increasing to the right. Likewise, 3 will appear before 4, and 10, so 0 will appear before 10, because to the left of 10, and so on. So we see that arrangement in the number line. Okay. When I say A is less than B, remember this means less than. That's how you read it. If you read it wrong, you will be explaining it and expressing it incorrectly, right? So we want to make sure that we use the right notation. I'll just say greater than, not more. We don't use. This is the more commonly used expression. A is greater than B. Now, when they explain this concept to young children, they talk about the alligator's mouth being open this way, that way. So you can take hint from that as well. So, well, you have when the symbol is arranged like this, you really have to read them correctly. Okay. Now, the equivalent expression for this would be, so this means, when I put the arrow head on just one side, it means implies. When I put it on both sides, it means implies and is implied by, meaning it's two-way. It works two ways. A less than B is the same as B greater than A, right? That's what this means. And likewise, if I say A greater than B, it's the same as B less than A. So you should be flexible in switching the order. And what happens when you switch the order? The symbol also reverses, right? Because if you didn't change the symbol, then you're just simply saying the opposite, not the equivalent statement. A greater than B would, if you didn't change the symbol, would be B greater than A, right? So you have to change their positions and change the symbol to make it equivalent, to make it a true statement. So here is a table that gives you all the symbols. Now we know the less than, we know the greater than. We do have two more such inequality symbols. So you have the less than with an equals bar, which is read as less than or equal to B. And we have greater than with an equals bar, which is read as greater than or equal to B. And then we have, of course, the equals and the not equals. Okay, when it says A not equal to B, you don't know which side is greater, which value is greater than the other. We just know that they are unequal, right? So we've got that. So we have for equality, we have the equals and not equals with a slash through the equal sign. And for inequality, we have these four symbols: less than, greater than, less than equal to, greater than or equal to. So I want to give a quick connection between expressions and equations, right? We spoke about that. Expressions are, of course, made up of an operation and a mathematical operation and numbers, equations has the equal sign. But to make it a little more specific, we can say, for like in English, this is an analogy for expression would be like a phrase. Okay, a phrase is actually an incomplete. It's a single thought which is incomplete. Okay. Whereas when we talk about equations, its analogy would be a sentence. So what would a sentence do? A sentence is not only a complete statement, okay? It has, let me write here. It's a complete statement. So it has a subject and a verb, isn't it? Making it complete. A phrase is an incomplete thought, so you can just say running very fast. Could be a phrase. But when you say sentence, then you can say the football player was running very fast. So you see how one is a thought, the other one is a complete statement. That's how expressions and equations are. So if I were to translate this into the math style, expressions would be like 3 plus 5. Okay, 3 plus 5. It's not complete. Okay, or I can say n minus 1. You see how it's just a brief way of saying a portion of a thing. But then if I were to use an equation, then I will say 3 plus 5 equals 8. Or I would say n minus 1 equals 14. Okay. Then we can say 6 times 7 equals 42. So the left side and the right side are the same, and then you now have a complete mathematical statement. Okay. So by way of defining it, I can say that an expression could be a number, a variable, like we saw, we used the n, right? Or a combination of the two, okay? So combination of numbers and variables and operation symbols. When I say operation symbols, equal sign does not come under that. Okay, so that is there. However, when we say equation, as I mentioned before, a mathematical expression will be equal to another mathematical expression, and so it's connected by an equal sign there. So that is the huge difference. Then when we talk about the language, so we have something called the grouping symbols. So the parenthesis is rounded and smooth like this. Then we have the brackets, which are boxy like this. Then we have the braces, which look like the curly brackets, right? Now, when we have nested grouping symbols, that is one inside the other, this is how it looks. Now, when we want to use just parentheses, when we want to use grouping symbols, when we want to group things together, bring two expressions together or something, we use the parentheses generally. But if you want to group two things one inside the other, we use the parentheses for the innermost and we use the bracket for the outer one. If I have 3 to group one inside the other, then the braces comes out as the overarching grouping symbol within which the bracket and the parentheses reside. So I'll give you an example here. Now, if I have to simply do this, then I use the parentheses. The grouping kind of tells me that I have to do that first because it's grouped together. It draws my attention. And so I just use parentheses here because there was nothing more complex than that expression. You could have something like this. So 21 minus 3 times 2 plus 4 times 9 minus 8. Look at this. Okay. So I have a parentheses inside the brackets, right? So this is an expression where it is lengthy and I've got to do more things. So the grouping is done in two levels, one nested inside the other. So I have the innermost and then the outer brackets. And you could also have something as complex as this. Look at that. So 24 divided by and this expression. So you can't divide the 24 yet until you took care of all these nested parentheses. Okay. We'll be looking at them under order of operations. So it is not something I'm intentionally giving you to make it look scary. No, we'll be learning how to use order of operations so we can come out of this unscathed. Yeah. All right. So we will now look at simplifying expressions with exponents. So notice the language. Okay. Exponents is also a kind of operation that we use. We'll get to that, but I just want to quickly help you understand. Simplify means reduce to the lowest terms. Okay. So meaning you are trying to combine them wherever possible. So if it's 6 times 7, you don't leave it as 6 times 7 because it's possible to combine that and give a product, the multiplication, as 42. So 42 would be the simplified version because you reduced it to the lowest terms. You know, expression means it is a collection, a combination of variables and numbers with the suitable mathematical operation. So it does not have, or I'll just say no equal sign. Right? It's just an expression. Now let's come to exponents. Exponents, what is that? That is a mathematical operation, and it's just like your addition, subtraction, multiplication, division. It does the job like that. So an exponent, what is an exponent? Exponent is a fast way to multiply repeated numbers. So it's quick multiplication. Notice how multiplication itself was quick addition of repeated numbers. Exponent is quick multiplication of repeated numbers. So if I were to multiply 2 times 2 times 2, right? You can rewrite this very expression as 2 to the power 3. Notice how it is a superscript, right? It's above the 2 written to the top right corner of that 2. So if you bring it lower, it will become 23, right? We don't want all that. We want to see it very distinctly as 2 power 3. So please make sure you give it the space. Don't try to save space or paper or pages by writing them so small or tiny that it's very hard to differentiate it. Okay? So 2 power 3. So 2 power 3 tells me that it is 2 that is being multiplied, and it's being multiplied 3 times over. Okay? This is not the same as 2 times 3. Yes? So it can't be the same as 2 times 3. So 2 times 3 will be 6. That would be meaningful if we did 2 plus 2 plus 2. Okay, so this is definitely not the same as 2 times 3. 2 power 3 means something else. So think about it. 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. So 2 power 3 is 8. 2 times 3 would be a 6. So that is wrong, isn't it? So what is this 2 power 3? Well, 2 power 3, let's write that here. This thing here, the 2 in the bottom, is called the base, and this 3 here is called the exponent. Okay, I usually use this example of a flag and a flagpole. Okay, so think of the flag and the flagpole here. Okay, it's an oversized flag there. Okay. Now the flag and the flagpole. So this is the flag and this is the flagpole. Now your flag can flutter in the air only when it's tied to the flagpole. A flag can't stand by itself. So think of your flag as your exponent. Okay. So the exponent or the flag is always attached to the flagpole. So the exponent is always attached to the flagpole, which is your base. So you always want to look at the exponent and see what it's attached to. It is attached to the 2. Okay. And that is how you know that this 2 is the base. The base is that it is a factor. A factor is an expression that is being multiplied several times to produce a result, a product. Okay. So I'll give you the definition here. So an exponential notation is defined this way. So for any expression a power n means to multiply n factors of a. Okay. So n factors, look at this. A is being multiplied how many times over? N times over. So the number of times it's being multiplied is the number of factors, right? How many times? Because it's the same a that's being multiplied. So a is multiplied n times over. When I say 2 power 3, then 2 is being multiplied 3 times over. So there's means to multiply 3 factors of 2. Okay. So when we have specific powers, like in this case, where we have 2 to the power 2, we call this as 2 squared. It's a special name, you could say, for the power 2. If it is 2 power 3, we call it 2 cubed. It's only for the square and the 3. If it's 2 power 4, we just simply say 2 to the 4th or 2 power 4. 2 power 4, right? So we do have specific way of expressing them if it is just a 2 or a 3. If the exponent is 2 or 3, we call them squared and cubed. If it is anything else, we just say 2 power 4, or we can just say 2 to the 4th power. 2 to the 4th power. Now, putting the power like that on the top right corner of the base, that's the exponential notation, right? To write it like that is known as the exponential form. So you can have a problem that says, write the given expression, right? Because there's no equal sign, in exponential form. And they can give you, let's say, we'll do a few problems. So the first problem would be 41 times 41. Now look at this problem, and if you look at it, you see that 41 is the repeated factor. Okay, the same number is being multiplied, not added. If it's being added, then we know quick addition of repeated numbers is multiplication. But here it's being multiplied. You can clearly see the multiplication symbol. So quick multiplication is exponential form, right? So what is being multiplied over and over and over again? It's 41, right? So how many factors for 41? 1, 2, 3, 4, 5. So 41 has 5 factors. So you write it as 41 power 5. You don't really have to expand it. When it's really, that's another thing with the exponential form, where you just write it as 41 power 5. We know where, if you expand it, it's going to be a very large number. But we can still keep it crisp as 41 power 5 instead of having to expand it. Because if we really need to know the number, we can go back and expand it. But it still preserves the value of that large number. Okay. So this is 41 with 5 factors. or I should say 5 factors of 41. That's not the ideal language, so let me write that here. 5 factors of 41. Okay. Now if I let's say a times a times a. Okay, I didn't give you a number this time, but I gave you a letter. Is that still possible to write it for a letter? Now look at this. The letter is the same letter that's being repeated, so it is as if it was a number. It's just represented now by a variable, a letter, which is totally fine. So we go back and count 1, 2, 3, 4, 5, 6, 7. So A has repeats 7 times by multiplying over and over. So A is the base, and it's being raised to the power 7 because it's being multiplied 7 times over. Okay. So here the base A is a factor. Another way to write this is base A is a factor 7 times. Yeah. And if I give you the other way around, if I said, what if you had 4 power 8? How would you expand it? Exponential form is the crisp or concise way of writing it. Expanded form would mean that you will have to write it out fully. So 4 has to be multiplied 8 times over. So this will be the expanded form. Right? Now if you had x power 5. Okay, again, I like to put my x as in cursive, a rounded x like that. That way it is not mixed up with a multiplication times symbol. So this would be x multiplied how many times? 5 times. That's right. So you got it 5 times. So you can do it both ways, isn't it? So you can do it as the exponential form or in the expanded form. Now sometimes they'll say simplify. Remember the language? Simplify means to reduce it to its lowest terms. So we can have simplify, and the question would be 3 power 4. So in this case, you definitely know it is in the exponential form because it's the exponent is 4, the base is 3, and you know you'll have to expand it. So 3 times 3 times 3 times 3. You cannot use the calculator, so you'll have to do it manually. So one of the easiest ways to do this is, I like to group them like this, right? 3 times 3 and 3 times 3. You know 3 times 3 is 9. Multiply it, right? 3 times 3 is 9. And 9 times 9 is 81. So it's kind of easy when you split it up like that. 3 power 4 equals 81. So that is the simplified form where you took the answer and multiplied it to get the final outcome, which was 81. Okay. What do you think is 1 power 21? You can go further and expand this by multiplying it 21 times. But is it necessary? It is not necessary because 1 power anything will come back as 1. So you really didn't have to expand it, but you can show it. You need to show work. For your exam, you can show it like this and say that it's equal to 1, right? So what about 0 power 12? Again, you don't have to expand it because if you did expand it, 12 times over, 0 times anything is 0. So here also it comes back as 0, right? So this is something that we have to remember when they say simplify, what is the end result. Now let's go to order of operations. When we speak about order of operations, it is absolutely important that what you learn here today will travel with you for all your math journey. Okay, so you can be doing very, very top level math. This order of operation, it will be something that you'll be using even in that stage, in that level. So this is something you really want to be very, very clear, because without the order of operations, you know, as the name says, operations here would mean mathematical operations, plus, minus, multiplication, division, exponents. So we have these things, and with the grouping symbols, how do we know what to do first in order to get the answer? Because if we didn't have the order of operations, a problem can be given like 50 different solutions just because we all used our own methods. So this kind of unifies and brings orderliness to the way in which we perform the operations. So here is how it goes. So you do the parentheses and all grouping symbols first. Okay, so you'll always simplify all expressions inside them, working on the innermost parentheses first. Okay, innermost grouping symbol. Then we do the exponents, because this is the order in which they will be given importance. Then it's the exponents, so you simplify all expressions with exponents. Multiplication and division, they come together because you know how they are related in a sense, right? So we will perform all multiplication division in order from left to right. These operations have equal priority. That is very, very important for us to remember, because when you look at it, when you look at your expression, when you read it from left to right, if multiplication comes first, then you will do multiplication. If division comes first, that's the first thing you'll do. So you really want to make sure that you perform these operations in order from left to right. Likewise, addition and subtraction also have equal priority. So you will perform addition and subtraction in order from left to right. Okay. So how do we remember this order? Okay. So we do have a way to memorize this. It's called the PEMDAS. Okay. Please excuse my dear Aunt Sally, PEMDAS, for parentheses, exponents, multiplication, division, addition, and subtraction. Okay. So the my dear is together and the Aunt Sally is together to help you to remember that M and D, multiplication, division, have the same priority. Addition, subtraction will have the same priority. Okay. So we have to always remember PEMDAS. Now PEMDAS is an iterative process. What does that mean? That means that in each level, in each layer, we have to keep applying the order of operations. So let's do a few problems, simple problems, just to drive home the idea of the order of operations, how it's important to follow this order. Okay. So they will say simplify, and I'll give you two problems. Okay. The first one says 4 plus 3 times 7, and the second one is 4 plus 3 in parentheses times 7. Let's see how we will approach each one. Okay. We also will be curious to see if they give us the same answer. So let's focus on the first one. 4 plus 3 times 7. Iterative means in each step you're going to do PEMDAS. Okay. So is there a P? Meaning, are there any parentheses or grouping symbols? No. Is there an exponent? No. Is there multiplication? Yes. Because multiplication division come together, M and D, you have to see from left to right which one comes first. There was no division, but there was only multiplication, so multiplication comes first. So that is what you will do in your step. For multiplication, you need two things to multiply. So here's the multiplication dot, so you know you have to multiply what's on either side of it. So 3 times 7 is 21. That's what you do. Now you'll have to do PEMDAS again. That's what I mean by iterative. PEMDAS. This is a very simple problem, therefore you do not see many operations here. Okay, we'll slowly build up to that. There's no P, there's no E, no multiplication or division. Addition, subtraction, again remember they have equal priority, so from left to right as you look at it in this direction, which symbol do you see first? Well, there is only addition, there was no subtraction, so there's only addition, so thankfully we only will do that. 4 plus 21 is 25. So for the first problem, the answer comes out as 25. Okay, let's do the second problem. 4 plus 3 times, you know what, I'll do it below because I'll need more room. 4 plus 3 times 7. So here again, PEMDAS. P, yes, we do have a P, which means the rule says you'll have to give priority to what is inside the parentheses. So inside the parentheses, I have 4 plus 3. Okay, it is pretty simple, so it is fine. Otherwise, you will have to perform PEMDAS inside the parentheses all over. But here it's just 4 plus 3, so 4 plus 3 is 7 times 7. So apply PEMDAS again. We took care of the parentheses, so there was no P, no exponents. Multiplication division, again from left to right, there's only multiplication. So we just do that, and we get 7 times 7 is 49. Okay, notice how they both read the same way, 4 plus 3 times 7, but one is grouped, one isn't, and you see how very different the answers turn out to be. So when you had the grouping, you had to do the group first and then the multiplication, but when you did not have that, you were free to do the multiplication first and then you will add it. Notice how it is very important to follow the order of operations to make sure that we did not fall into some trap, right? We'll do a similar one here. How about, let's say, simplify 1, 18 division 9 times 2. 18 times 9 division 2. Okay, so I'll try to squeeze them both here side by side. The first one is 18 division 9 times 2. So if you look at PEMDAS, it's with multiplication and division. So from left to right, which one appears first? Division appears first. Okay, so division takes, even though it is PEMDAS, you know, M and D are equal. So division comes first. So we will focus on this division first. So what is 18 divided by 9? Again, for division, you need to divide two things, the two things on either side of the division symbol. So 18 divided by 9 is a 2, right? So 2, and then bring down that times 2. Then once again, you do the PEMDAS. Here, no problem, because it's only multiplication that's present here. So 2 times 2 is 4. And that is the answer here. Okay. So for number 2, it's 18 times 9 divided by 2. Here again, we do the PEMDAS. And we know that M and D are equal. There's no P or E. M and D are equal. But from left to right, which one appears first? It's the multiplication that appears first. And so we will have to do this multiplication first. So 18 times 9. So let's do that multiplication. It all has to be done by hand. Right, no calculator. That's 72. 9 times 8 is 72. 9 times 1 is 9. 9 plus 7, 16. So that's 162. Bring down that division 2. Once again, you have the PEMDAS. No confusion here because division is the only symbol that is there. So 162 divided by 2. So let's do the long division, 162 divided by 2. 2 times 8 is 16, that's a 0, bring down the 2. 2 times 1 is 2, and the remainder is 0. So the answer is 81. Okay. I went through the division a little quickly, but you can always pause the video and do it completely, you know, as part of your notes taking. So you can see how, you know, things have changed dramatically. Here it was a mere 4, but there it became an 81 because you divided here first and then you multiplied, so you reduced the value and then multiplied it. But there you multiplied it first, which means the value increased, and then you divided it. Therefore, it gave you a bigger number. Also, with the play of numbers, you know, itself will make a world of difference. Okay, simplify 18 division 6 plus 4 times 5 minus 2. Okay, PEMDAS. We have the P. Okay, so we have to do this first. So you will have to write down everything as it is until you have taken care of this. 4 minus 2 is 3. Okay, we did that. Go for PEMDAS again. Now, do we have the parentheses? Yes, we have the parentheses because I could not drop it because it was, if I dropped it, it'll become 43, isn't it? Yeah, 4 and the 3 will come together. So it's not the case. So I have to keep the parentheses. But is there anything happening inside the parentheses? Do I have to operate inside the parentheses? No, there is nothing to operate inside the parentheses. There's only a number 3. However, the parentheses now begins to play the function of a multiplication symbol, right? Because it's a 4 and then a 3. So we now will treat this parentheses not as a P, but we'll see it as an M, just because of the fact that there is nothing to operate inside the parentheses. So there's no P, there's no E. M and D are equal. So from left to right, which one comes first? D comes first. So division is what takes priority here. So 18 division 6 will be 3, right? 18 divided by 6. 6 times 3 is 18. So we got that done. So 3 plus 4 parentheses 3. So do PEMDAS again. Remember, it's iterative. Once again, this P, this is not considered as P. It's considered as not as parentheses but as multiplication. So no exponent. And then from left to right, M and D, there's only an M, no division here. So we do this next. So that's going to be 3 plus 12. And then we do the PEMDAS again. At this point, it becomes so intuitive, you do not think of PEMDAS, but I want you to understand that that's all happening there still. Okay, so there is only addition, there's no subtraction. So we do the 3 plus 12, which is 15. Okay, when things become a little more intuitive, like 3 plus 12, we tend to drop off PEMDAS. But remember, it is happening. It has always happened, but now we are given the information because we are now loaded with more expressions within the statement. So we are able to apply PEMDAS in a more detailed manner. Yeah? All right, let's do another one. Five plus 2 cubed plus 3 times 6 minus 3 times 4 minus 2. Okay. All right, let's start with PEMDAS again. This one is loaded with with grouping symbols. So what their rule said was, when you have nested groups like this, you know, a group inside a group, you start from the innermost. Okay, innermost. That's what you will work on first. So right now our priority is all about the parentheses. So copy down the other details as it is. You're not touching them yet. Okay, so I'll keep this bracket too, because it's only the parentheses that we are interested in at the moment. So 4 minus 2 will be 2. Remember to keep the 2 in parentheses, because if you drop the parentheses, it will become 2 together as 32. So that will be wrong. So now let's go to PEMDAS. Do we have a P? Yes, we do have the parentheses inside, but that has no operation inside, so it is treated as multiplication. But we do still have another P, which is the bracket. Okay, so then our focus is now this bracket, because you took care of the innermost. Now we go to the bracket. So once again, copy down all that you have here and only focus on this. So inside this, okay, inside this, you'll have to do PEMDAS. Okay, PEMDAS inside PEMDAS. So within the bracket, it's as if it's a separate problem, right? Because the bracket is kind of protecting it as a separate problem. So within that, what do you see? Do you see parentheses? yes, but no, because that is now multiplication. So you do have multiplication division. So from left to right, there is no division, there's only multiplication. So we got that. So that's going to be 6 minus 3 times 2. Let me do this. Okay. 3 times 2, which is 6. 3 times 2 is 6. Okay. Now we are still inside the parentheses, and we're still going to do the PEMDAS inside the parentheses. In this case, not parentheses, but you know, it's actually a bracket. But P stands to represent all these grouping symbols. So there's no operations here except the subtraction, 6 minus 6. Okay, so that is what we're trying to do. Once again, we are keeping everything as it is. Don't be in a rush, because if we did it in a rush, we would skip out on the steps, and we're still learning. When you get really, really comfortable, then you can move fast. Okay. All right, so we took care of this. 6 minus 6 is 0. Okay, just because it's a 0, don't just ignore it. You have to write it there, because, and again, you can't drop the bracket, because if you drop the bracket, it would become 30. Right? So we got that. Now back to the blue PEMDAS. The red PEMDAS was what happened inside the parentheses, right? So back to the whole problem PEMDAS. So there is no P because this bracket serves as parentheses. Oh, is there an E? Yes, there is an E. So our focus is now on this one. Okay. So I write the 5 plus 2 cubed. What is 2 cubed? 2 times 2 times 2. 2 cubed is 2 times 2 times 2. 2 times 2 is 4. 4 times 2. 4 times 2 is 8. So that's going to be 8 plus 3, 0. Okay. Don't do them all in one shot. Do them one after the other. Alright, so there is no P, there's no E. Is there an M or a D? They're equal. Yes, there is a multiplication here, right? So 3 times 0. What is 3 times 0? Anything times 0 is 0. We saw that in the multiplication property of 0. So 3 times 0 is 0. So I keep the 5 and the 8 as it is. At this point, it's become really, really intuitive. But remember again, as I mentioned before, PEMDAS is still in effect. So addition is what we do. 5 plus 8 plus 0. 5 plus 8 is 13. 13 plus 0. Technically, there is another PEMDAS. So, because we're doing 2 at a time here, right? Again, there's addition. 13 plus 0 is 13. Okay, again, bear with me if these things seem too intuitive. You can't be too careful. And I'm trying to here teach you the order of operations. And therefore, I'm showing you how it's important to apply it in every step until you've reached the final numerical value. Okay, we'll do another one. Two cubed plus 3 power 4 division 3 minus 5 squared. Now if you feel confident about the method, please pause the video, go ahead and complete the problem. Okay. Alright, so now we have PEMDAS. We do not have a P, but we do have E, and notice how we have E in 3 places. So we have to do it in 3 places simultaneously. Okay, so that's nice space for us. We just saw 2 cubed was 8, so we don't have to expand that. 3 power 4, we saw this also in another problem, but I will show it to you again. 3 times 3 is 9, times 3 times 3 is 9, 9 times 9 is 81. So 3 power 4 is 81. Then we have 5 squared, which is 5 times 5. Again, don't be in a hurry and do 5 times 2. That will totally mess things up. So 5 times 5 is 25. So I want to replace all these values by their expanded answers. So 8 plus 81 division 3 minus 25. Okay, so we have this and this. Now we have PEMDAS. No P, no E, we took care of the E. Multiplication, division, from left to right, which comes first? There is only division that comes first, no multiplication. So this is the next thing you'll have to do. 8 plus, so you can do the 81 division 3, long division, or you can do the short division 2 if you're up to it. 3 times 2 is 6. 8 minus 6 is 2. Bring down the 1, that makes it 21. 3 times 7 is 21, a 0 remainder, so the quotient is 27. That goes here, 27 minus 25. Now do PEMDAS. PEMD, there's an addition and subtraction, so they are equal in value and priority. Therefore, whichever comes first. So from left to right, plus comes first, so this is what you will do first. Okay, 27 plus 8 will be 35 minus 25, and now you can already see what to do. Nevertheless, we have S. Subtraction is the only thing that's happening here. So do this, 35 minus 25, which is 10. And that is your answer here. So we looked at plenty of examples, and I did I did all of them thoroughly. In fact, I went over the multiplication, division, and the exponents by doing them by hand to show you that we're not using a calculator to compute some of these. We did them everything by hand. So please make sure you practice doing these without a calculator. All right. I hope you enjoyed this video. I will see you in the next one.